All right, welcome to a discussion that is not on any particular section. Well, it probably is, but we talked about domain a couple of times, and I can't remember what section it is, so I don't know what section to reference. But this is on domain. So the basics of domain, the domain of a function, let's say some function f of x. The domain of f of x is simply the set of numbers for which f of x is defined. Right? In English, it is all of the numbers that I can plug into f of x and have f of x spit out a number, right? So if we're looking at simple functions like a polynomial, or something very simple like 2x, right? If my function is 2x, I have to think what number could I double and get a valid output, and that's all of them, right? So we really kind of try to look at where it falls apart, where things don't work. Are there any numbers I can't double? Well, no, because every number could be doubled and you have some double, right? If we get a little bit more, let's say I have some g of x, let's call it, is 3x squared plus 5x plus 2, right? Is there any number that I couldn't square? I could square any number, and then once I get that number, could I multiply it by 3? And yeah, every single number I can do that. I can take any number and multiply it by 5, and I can do both of these things. There's nothing that I can't put in here. And so polynomials, whenever it's just something x squared, something x to the third, x to the fifth, whatever, polynomials have domain of all real numbers because there's no number I can't plug into this and have it just pop out a valid output, right? So my domain, all real numbers, when I'm dealing with something as simple as a polynomial, right? We start to look at issues when we have things like square roots. So let's look at a function. Very simple square root, the square root of x, right? The issue here is I cannot square root a negative number, right? I can square root 0. Square root of 0 is 0 because 0 squared is 0. I can square root all the positive numbers, right? Square root of 4 is 2, the square root of 9 is 3. Those are the nice ones. The square root of 1 is 1. But even the square root of, say, like 2 has a valid number. It's like 1.6 something, right? Or 1.4, 1.414, I don't remember. Blah, blah, blah. Throw it into a calculator, you'll get something, right? It may not be nice, but there is a square root. But what there isn't is a square root of negative 2. This is not a real number. And that's where we have our issues, right? When I try to square root a negative number, I'm no longer in the real number line, okay? So that affects our domain. So whatever is under the square root, right? Whenever I have the square root of whatever's under here, let's just call it blah for now, right? The requirement is that this blah has to be greater than or equal to 0. So my domain issue is that blah, whatever that expression is, if it's just an x, if it's something, polynomial, if it's something bigger than just an x, whatever it is, that has to be greater than or equal to 0, right? So for example, I might see something like the square root of 2 minus x, right? Well, this implies then whatever's under that square root, that 2 minus x, has to be 0 or more, which is to say 2 minus x has to be greater than or equal to 0. And I can simply solve this to figure out where those values are. Say subtract 2 from both sides. That leaves me with negative x being greater than or equal to negative 2. Divide each side by negative 1, which will flip this sign. That leaves me x is less than or equal to 2. And that's my domain. That's the only place where I have x values that when I plug in here give me a positive number that I can square root, and therefore that is my domain. If I go to numbers greater than 2, like say 5, 2 minus 5 is negative 3. I can't do that. I have the square root of negative 3, which is not real, right? And therefore, I have my domain simply by following that, kind of process, right? So I have square roots, so that's my first domain issue. The second domain issue that we will see is dividing by an expression. Right. So if I have, say, something like 2 over x, let's call this f of x. If I have a function here, x can't be 0, because if x is 0, then I get 2 divided by 0, and we all know that's when bad things happen, right? I can't divide by 0, and so that's my issue. The issue is that you cannot divide by 0. And similar to the square root problem, that doesn't necessarily mean that x can't be 0 for every single one of these problems. It means that the denominator can't be 0, right? And so if I have an expression, let's call this g of x equals whatever, x over x minus 4, right? I don't really care about the numerator here so much. What I care about is that this denominator cannot be 0. And therefore, I say x minus 4, the denominator, cannot be 0, and this defines my domain, right? So if I add 4 to both sides, x cannot be 4, right? It can be anything else, including 0. If it's 0, I simply have 0 divided by 0 over negative 4. That is 0 over negative 4. That's 0. That's valid. That's a number. Right? We're good with that. I can't divide by 0. So that is to say x can't be 4, because if it is 4, 4 minus 4 gives me the 0 in the denominator, and the world explodes. Right? So those are our two basic domain issues. We will, in this class, talk about something else called a logarithm later on. Maybe. I might be lying to you. I can't remember now. Let's see. Yep, they're coming. In chapter 4, logarithms are right around the corner. You may have seen them before. If you're in if there's no if, you're in pre-calculus, so you may have seen them before in an algebra class. But that will bring more domain issues. But for now, these are the only two that we really care about, is that you can't have a negative under the square root, and that you can't divide by 0. Now if I have some function that has multiple issues, let's say that I have some function f of x equals x over the square root of x plus 2. This x up here doesn't matter, it's just a polynomial, and the numerator doesn't matter. The numerator can be 0 all at once. It's the denominator that it can't be 0, but I also have a square root. So I have two issues. I have the square root, and I also have the denominator. Okay. There's two issues here that I have to make sure that both are satisfied, and therefore I essentially get an AND conjunction. I'll have some domain for my square root, but I have to intersect that with the domain of the denominator, right? So for the square root, it's simply x plus 2 has to be greater than or equal to 0. And I'm not going to solve this because I'm going to simplify my life before I do that, right? The denominator simply says that the denominator can't be 0, and therefore this x plus 2 can't be 0, right? And the intersection of these two things, since I have the same expression x plus 2, has to be greater than or equal to 0, but then this says x plus 2 can't be 0, I can combine these into a simple expression using the and, that is then x plus 2 simply has to be greater than, strictly greater than 0. It just eliminates the possibility of it being equal to 0. And therefore I subtract 2 from both sides and I get x is strictly greater than negative 2, and that's my intersection, right? If you did them separately, you would find that x has to be greater than or equal to 2, but then this guy says you need to remove the negative 2, and therefore it's from negative 2 to infinity, not including the negative 2. Okay. Let's say I have something just idiotorous here, like g of x equals the square root of 3 minus x over the square root of, I don't know, let's say that. Yeah. Now I have to, again, satisfy 3 conditions here, right? So condition 1 is that I have a square root in my numerator, so I still can't have that square root be the square root of a negative, so I have to satisfy that 3 minus x is greater than or equal to 0. Condition 2 is the square root of the denominator, that is to say that x plus 5 has to be greater than or equal to 0. But then condition 3 is that that square root in the denominator can't be 0, so that is to say that x plus 5 can't be 0 itself, right? I'm going to solve all 3 of these separately, right? I'll spare you the tedium here. This is going to end up being x is less than or equal to 3, right? If you subtract the 3, divide both sides by negative 1, you get x, flip the sign to be less than or equal to 3. Similarly, I'm going to get x is greater than or equal to 5, right? And then this x can't be, sorry, this is a negative 5. X can't be negative 5 itself, right? So that is to say, if I look at all 3 of these, and I'm going to erase what's above here for a moment so that I can draw this. The first one, x is greater than, less than or equal to 3. So there's 3. It's less than or equal to, so solid dot shaded to the left. Okay. The second one is x is greater than or equal to negative 5, so there's negative 5, open, solid, shaded to the right. And then the other one is simply an open at negative 5, but everything else is fair game, right? But again, similar to the last one that we did, this negative 5 simply removes the negative 5. So I'm going to collapse these two. The intersection of the bottom 2 is simply taking out that point at negative 5. And now I don't have to consider this anymore. But I'm still looking for the intersection between these two. And so you can see that it's between negative 5 and 3, not including negative 5, but including 3. And that's my domain, the intersection of all 3 issues that I have, right? All right. Hopefully that was helpful. Like I said, we're going to see some more domain issues. When we hit logarithms, you'll see domain issues in pre-calculus 2 when you start talking about trig functions, things like that. So there's more functions that have interesting domain issues, but for now, we've just got the 2, and we'll see a third one soon. Hopefully this was helpful. All right, see ya.